Alright, so today we're going to work a question where we have a car parked on a cliff overlooking the ocean that is inclined and makes an angle. And so we've got a car, it's parked on a cliff, and apparently we've got a negligent driver who didn't set the brake, left it in neutral, a whole host of things goes wrong. But the point is that the car begins to rolls down the cliff, and then of course at the edge of the cliff, tragedy strikes. Off the cliff it goes and descends at that point in a parabolic trajectory and ends up crashing into the ocean or whatever's below there. All right, and so we're going to have to work this one in two parts because we really sort of have two different physical things going on. Number one, we've got the car that's going to roll down the cliff to the edge of the cliff, and so we'll need to do some work there and find out a couple of values. And then part two, the car is actually going to then go over the cliff and descend and strike the ground. So that's going to be what we're going to look at here. All right, so part one, which I'll work in purple. So part one, which I'll work in purple. So I'm going to go ahead and erase this track. That'll be part two. Okay, so part one, which we'll work here, sort of in purple. The car, it says, starts from rest. And so we've got VI is 0 meters per second. All right, and on my question, theta is 23 degrees. All right, so the car is parked on the cliff overlooking the ocean on an incline that makes an angle of 23 degrees below the horizontal. That just means that the angle of the cliff, whether you drew the horizontal there and measured down or drew it here and measured up, those thetas are going to match. So I've drawn mine there. 23 degrees below the horizontal. We've got our negligent driver, and then it says the car rolls from rest down the incline with a constant acceleration of 3.9 meters per second squared. Of course, your numbers will vary. Your number will not, may not be 3.9, but that's the number that I'm going to use while I'm working here. And it travels 53 meters. So 53 meters is the length of this roll, and so that's just going to be its displacement. And so I'm just going to label that as delta x, 53 meters. And so it's going to roll down there to the edge of the cliff. And then it says the cliff itself is 35 meters high, so I'm going to begin writing in a different color for the second part. And so that cliff then is going to be 35 meters high, obviously not drawn to scale. And then it says how long is the car in the air. Okay, so ultimately we're asked then for t, for how long the car is in the air following its projectile path down to the ocean. All right, and so that's what's happening. Now, what's going on here? The initial velocity here is 0, and then it rolls down the slope. And then right here at the edge of the cliff, right before it goes off, well, whatever its final velocity is at the end of the cliff is going to be the initial velocity as it then transitions off the cliff. So we need to find VF as it rolls down this slope, and that will then be VI for part two of the question. So what we're going to do is find VF here. I'm going to do that by just kind of looking at what we've got here. Well, we don't have time, and so that means I'm going to have to use my timeless formula. VF squared equals VI squared plus 2 times A times delta x. So looking for VF, and VI was 0, 2 times, and my acceleration is 3.9, and delta x for me is 53. So I'm going to take just a moment and solve that for myself and find VF. All right. And so at that point, I got for my number 20.3322 meters per second. And so it turns out that is how fast it's going at the end of the cliff, at the end of its roll down the slope, and that is then going to be VI for our next part. Okay, and so VF for the purple is actually then going to be VI for the red. I'm going to take this arrow and I'm going to redraw it just in a slightly larger area over here. So that's then going to be VI for how fast it. So this car leaves the cliff at 20.3322 meters per second. However, it's not straight off the cliff at that speed. It's downward at a 23-degree angle, because the angle that it was rolling at here is also the angle that it then descends and leaves the cliff with. So that's VI, and there's my angle, and I'm going to need to use sine and cosine and break that up into VIX and VIY. And so in doing that, VI times sine theta will equal VIY. In other words, 20.3322 times sine 23 will equal VIY. And I'll get a value for that in just a moment. And then, of course, I would do the same thing with cosine to give me my adjacent side, which would be VIX. And so I'll work those. And so then you'd substitute it exactly the same way, but with the cosine function. So I'll pause and calculate that for a moment. All right, and so I did my calculations there with my sine and cosine. Now, this is a projectile question, so I'm going to go ahead and make my XY table. And I'm going to shorten these numbers up just a little when I write them. And so my X velocity then is going to be 18.7 meters per second. And remember that that x velocity is going to be constant because there are no forces in the x dimension, and so there's no forces, there's no acceleration, so that value will be the same all the way through. And then I'm going to write down VIY. Now this is an initial; it's going to be changing, and it is downwards at 7.9 meters per second. Now this is downwards, and so you can decide if you want that to be negative or positive. Everything in this question is going to be happening downwards, so I'm going to choose to just leave that as positive, so I don't have to keep up with negative signs. So delta y is actually then going to be the height of the cliff, which was 35 meters. So delta y is 35 meters. And we know that the acceleration, of course, is due to gravity, and that's going to be 9.81 meters per second squared. Again, that's downwards. All of these are downwards. All of them should have the same sign. I'm going to leave that as positive just so that I don't have to keep up with any negatives through my work. If you would like those to be negative, though, that'll work out perfectly fine. Just be sure that you also then maintain a negative sign for anything else headed downwards. What we really want to do now is to find time. That's what we're going to need. That's what number 11 actually asks for, is the time, and so that's what we need to find. And you actually have enough information now, if you're willing to use the formula delta y equals VIT plus 1/2 AT squared, you actually have enough information to work that straight away. However, since there is a VI term and an A term, you would actually have to solve the quadratic equation or solve that in some other way in order to get time. I know that many of you are going to be reluctant to do that, so what we're going to do instead is we're going to actually use two steps. We're going to find VFY first, and then we'll come back and find T in the second step. So take a good look at this, and then I'm going to click over and give us a bit more space to work. So from right here, we're going to find VFY. Since we don't have time, we'll use our timeless formula. VF squared equals VI squared plus 2a delta y. We're solving for VF. And VI in this case is my long number from there, 7 point. We're working in the y dimension, remember, so we only need to use numbers from our y dimension. So that's going to be 7.9 and some change. Use your whole number since you're working for the computerized homework side. So VF squared equals VI squared plus 2 times A, 9.81, times delta y, which then is going to be 35. All right, so then if I take that and crunch all those numbers, I'll get a value for VF. I'm going to pause and do that. All right, and so at that point, I came up with 27.3827 meters per second for my final velocity. Remember that that is downwards, and so that needs to have the same downward sign that you gave all of these earlier. I had mine as positive, and so mine's going to remain positive. Although if you had selected that as negative, then you need to choose the negative root as your answer, your solution here, whenever you take the square root. So that was that's mine right there. At that point, then, we're going to take that number and put it into VF equals VI plus AT, and we're getting quite close here to our goal. So VF equals, I'm just going to again shortcut this, 27.38 equals VI, which I shortened to 7.9, plus A, which we know is plus 9.81 times T. These should have the same sign at this point because they're all downwards. So what I'll need to do is I'll need to take this and subtract that from both sides. So 27.38 and some change minus my answer from earlier. And I'm going to get then 19.43, etc. And then I'm going to divide. Okay, so at that point, then subtract that and get 19 and some change. Again, I'm shortening what I'm writing, but I'm using the full number on my calculator. That equals 9.81 T, and so then I will take 19.4 divided by 9.81. Again, using the full numbers on my calculator, and get a value for T. And so at that point, I'll divide by 9. And so when I did that, then I ended up with a time of 1.9815 seconds. And so that will actually be my answer for number 11, happy times. So that time then I'm going to write, now that's going to be our time for both sides, so I'm just going to go ahead and write that on the X side. It would also be on the Y side as well, 1.9815 seconds. Then you go on to part 2 of this question, and it actually asks you for how far away from the base of the cliff that object, that car lands. And so at that point, it's asking you for delta x. The way that we'll find that, I'm just going to scribble that in green right here in the middle real quickly. I'm going to use my x equation. This is an average velocity equation, so I can use it in the x since my velocity is constant. Can't do that in the y because your velocity is changing, but you can in the x. So at that point, then I'll take my velocity in the x, which is given here, and I will multiply it by my newly acquired time, and that will produce delta x, and that will actually then be our answer to number 12. So for me, I would put in my initial x number, 18.7159, and my time, 1.9815. Multiply those, and the product will be the answer to number 12. And hopefully you'll get that correct and have a lovely smiley face on your paper. All right, I hope that's helpful. Have a lovely day.